Hello everyone, my name is Alexandros from Team 5. We have been working on the MotionInput project, specifically in the implementation of facial navigation, development of the feedback portal, and creation of in-air macros. Our key requirements have developed through time, as we are a part of a larger group that developed facial navigation. We were responsible for the implementation of the eye grip mode and its combination with nose grip mode to make the final facial navigation system. Furthermore, we worked on implementing Ask KITA within facial navigation and on developing in-air macros. Lastly, we created a feedback portal for our system. We have extensively tested floating mouse through literature reviews and concluded that it was not optimal. Thus, we decided to create a simpler and easier to use model called the grip mode. The main libraries that were used is dlib for the calculation of the facial gestures, OpenVino for the evaluation of a vector from the user's eye gaze, and noitka for the compilation of the program. As mentioned, floating mouse was inaccurate and hard to use. Therefore, we used it as a base in the new architecture to develop grip mode that offers extended control to the user. Facial navigation is consisted of two main modules, eyes and nose navigation. In our presentation, we will focus on eye grip mode. The cursor can move at the four basic directions, up, down, left and right, depending on where the user is looking. To determine the movement of the cursor, we have implemented a calibration procedure that determines the extreme values in each direction. The eye calibration has overcome the floating mouse's need to have the dimensions of the screen manually inputted, thus setting the program able to run in machines of any dimensions or camera positioning, as all the calculations are made in relevance to the calibrated extreme values. The capabilities of eye grip mode are relatively high, as, after testing, we have determined that the user can move up to 1.7 meters away or 20 centimeters close to the camera while using the program efficiently. The available facial gestures we have implemented for the latest micro build are fish face for left click, open mouth for right click, raise eyebrows for double click, and smile to stop the movement of the cursor, independently of where the user is looking. The capabilities of facial navigation with Ask KITA speech commands are obviously extended. Presented here are the speech phrases that, if set by the user, trigger the relevant action. Some of the most important out of those consist of transcribe, where the user's phrases are directly converted into text, next mode to navigate between the different modes, and reset to redo the calibration. There are measureless scenarios where facial navigation can be used. For example, imagine trying to find a restaurant in a specific area and make a booking. By making use of the transcribe command, I can type my request in a search engine and discover my restaurant of preference. Then, if I would like to enjoy my dinner with friends, I can use the copy functionality to get the name of the restaurant, open the run window with the relative command, and create a new email for my friend after pasting the name of the restaurant. Navigation of web pages in social media is also another option, which is here demonstrated using facial gestures rather than speech commands. In-air macros are in the initial stage of development. We are trying to map a simple gesture to a sequence of events. We have designed an external program that works as a JSON file editor to add new events to the main code. This works in conjunction with Ask KITA to add, edit, select, and delete JSON entries. One of our main concerns was receiving feedback from the users on the existing software. Therefore, we created a prototype of how we imagined the feedback portal was going to be presented. Then, we developed a feedback form which allows users to give their feedback on what applications are easier to work on different operating systems, and comment on aspects they liked and not. This feedback portal exists as a part of the website we developed on facial navigation. This website also includes information page, instructions, along with a download link. Thank you for your attention.